How many minutes are in 2.45 hours? Now, I know this doesn't seem like a chemistry question, but in this lesson, we're going to learn a technique that is used to solve nearly every type of chemistry problem. This technique has several different names, but the most common are dimensional analysis and the factor label method. Dimensional analysis is a simple tool for solving problems, not just in chemistry, but in everyday life. It allows us to convert a number from one unit to another unit. If you ever need to figure out how much carpet to buy for your living room, how much it will cost, or how long it will take to travel somewhere, you can use dimensional analysis. Not only will using it help you stay organized as you solve problems, but it will likely reduce the risk of errors by providing a way to double-check your work. So let's go back to our initial question. How many minutes are in 2.45 hours? My number one piece of advice for answering a question like this is to try not to do it in your head or take any shortcuts. It may seem like an easy question to answer by punching in numbers into a calculator, but when the problems start getting more complicated and more abstract, you will be more likely to make mistakes if you don't use this method to solve problems. So let's start the process of answering this question by first reviewing 3 basic math rules. First of all, what do you get when you multiply a number, let's just say x, by 1? Hopefully you said the original number, or x. Multiplying by 1 does not change the value of the original number. You can always multiply by 1 without changing a number's value. Next, let's take a look at some of the properties of fractions. You would solve 2/4 times 5/2 by multiplying across the top to get 10 and by multiplying across the bottom to get 8. But because you have the same value, 2, in both the numerator and the denominator, these numbers can cancel out, reducing the amount of work you would need to do in the end by simplifying the 10/8 fraction to 5/4. But what if you have something like 5 centimeters times 1 meter over 100 centimeters? Can you cancel out the units as well? Yes. Identical numbers and units on the top and the bottom of multiplied fractions will cancel each other out. Finally, we need to examine what a measurement really is. If a reaction takes 1 hour, there are several different ways we can record this. 1 hour, 60 minutes, 3,600 seconds, and so on. There are multiple ways to write a measurement without changing its value. In dimensional analysis, we will use conversion factors to express these equalities. A conversion factor is a relationship in the form of an equality. For example, 7 days equals 1 week, 60 seconds per 1 minute, or 12 inches per 1 foot are all examples of conversion factors. Some conversion factors may be difficult to identify. For example, the density of aluminum is 2.7 grams per cubic centimeter. How do all of these rules help us solve our problem converting 2.45 hours into minutes? We will first want to start out with the quantity we are given with. Then we will need to set up a conversion factor or a group of conversion factors that will allow us to solve the problem. When setting up a conversion factor for this problem, we need to identify our known equalities. In this situation, we know that 1 hour is equivalent to 60 minutes. We can either write our conversion factor as 60 minutes over 1 hour or 1 hour over 60 minutes. We're going to need to choose which one of these conversion factors to help answer our question. So which one do we use? Let's see what happens with each one. If we take 2.45 hours and multiply by 1 hour over 60 minutes, which is equal to 1, we get a value of 0.041 hours squared over minutes. If we take 2.45 hours and multiply by 60 minutes over 1 hour, also equal to 1, we get a value of 147 minutes. If we compare these two answers, we need to understand that both of them are equivalent values, but one gives you the units you want and one does not. Let's take a slightly more challenging example. Convert 2.3 miles into centimeters. First, let's list our conversion factors, the information we will most likely be using to solve this problem. We have 1 mile equals 5,280 feet, 1 foot equals 12 inches, and 1 inch equals 2.54 centimeters. There may be some conversion factors you will need to memorize, but we will discuss those as needed throughout the course. For now, just focus on setting up the problem using the conversion factors. This is where it gets fun. We can solve this almost like we would play a game of dominoes. If you are given the tiles shown, and you have tiles A, B, C, and D in your possession, you will need to place them in an order that allows you to connect to the 2 on the right side of the sequence. This may take a little trial and error and a little problem solving, but you should come up with the sequence given tile B, tile A, tile C. You may think you could use either tile C or tile D for the last placed tile, but tile D wouldn't work because it doesn't connect up with the 2 on the last tile. We can use the same exact process to convert 2.3 miles into centimeters. We start out with 2.3 miles, but because we don't have a direct connection in the form of a conversion factor to centimeters, we need to plan out how we are going to set up our fractions so that the units we want canceled out will end up being on opposite sides of each other. So we will start out with 2.3 miles. The conversion factor that includes miles is 1 mile equals 5,280 feet. Are we going to write the fraction so the miles are on the top or on the bottom? Miles should be on the bottom in this situation because we are trying to cancel out miles. Placing it this way allows us to cancel out miles, but the remaining unit is feet, which we don't want. We will have to use another conversion factor to convert from feet. If we use the conversion factor 1 foot equals 12 inches, would we want to place feet on the top or on the bottom of the fraction? In this situation, we would place it on the bottom. So we would multiply by 12 inches over 1 foot. This cancels out feet, but we are still left with inches. We need to convert to centimeters, so we place our final conversion factor in the line in a way that allows us to cancel out inches and convert to centimeters. So inches would need to be at the bottom. If we multiply everything out, we get 370,000 centimeters. The biggest issue people have when converting units is they're not sure whether to multiply or divide. If you set up every problem just like this, it should become clear whether you will need to multiply or divide, and you will reduce your risk of error. Let's finish with a slightly more challenging problem. For this, let's use the density of ethanol, 0.8 grams per milliliter, and convert it into kilograms per liter. First, we will list our conversion factors. We know that 1,000 milliliters equals 1 liter, and 1,000 grams equals 1 kilogram. So how will we set this up? Always start with the value that the question gives you. In this case, it would be 0.8 grams per milliliter. We may see right away that grams is in the numerator, and we would like it to be kilograms. So we're first going to multiply by 1 kilogram over 1,000 grams, which allows us to cancel out grams. Next, we will convert milliliters on the bottom to liters on the bottom. To do this, we'll need to manipulate our conversion factor so that milliliters is on the top. We will multiply by 1,000 milliliters over 1 liter. This allows us to cancel out milliliters, leaving liters in the denominator. You may also see that the 1,000s will cancel out, leaving us with 0.8 kilograms per liter as the final answer. Keep in mind that when you multiply numbers, the order does not matter. So if you wanted to cancel out milliliters first and grams second, that would work just as well. When you're solving these types of problems, just remember it takes a little planning and a lot of practice. We will be solving problems using this method for the rest of the course. Even if you think you can solve these types of problems quickly and in your head, you should still learn this method because it will greatly reduce the number of errors you make in calculations. Also remember that even though it doesn't look like it, all you're doing is multiplying by 1, which is okay because it doesn't change the original value of the number.